Welcome back, dear students. So today will be the last class on tangents and normal from AOD. Okay, and the main topic and the last topic in fact of tangents and normal is called angle of intersection of two curves. As the name suggests, we are going to find what is the angle of intersection between two curves. Okay, so let's say there's one curve like this. Okay, so this is one curve. Okay, and let me call this equals to y equals to fx. This is your one curve. Okay, now let's say we have got another curve. Okay, so another curve to be this one. Okay, so let me call this to be y equals to gx. This is another function. So basically here I want to calculate angle of intersection between them. So since we are talking about angle, so we will be actually talking about acute angle. Okay, acute angle less than 90 degree. Okay, now basically if you see here, this is the acute angle, isn't it? Theta, right? So I'm interested in finding what is this theta, but just by using the equation of the curves I will not be able to find out the equation out here. I'm sorry, I will not be able to find out the angle out here. So what am I going to do is I'll just draw two tangents at the point of intersection. Okay, so at this point I'll draw two tangents. Okay, so for example, let me show you. So this is one tangent. So at this point I'm drawing one tangent. So let's say this is the tangent. Okay, and this is the tangent for y equals to fx. Okay, and let's say its slope is m1. Let's say its slope is m1. Okay, now what am I going to do is, obviously, see, if this is your m1, if this is the slope, then its slope will be nothing but dy by dx for this derivative of this will give you the slope of this tangent, isn't it? Because this is the tangent to the curve y equals to fx. Similarly, what am I going to do is I'll draw tangent for this curve y equals to gx at the same point. Okay, so at the same point, if I draw the tangent, your tangent looks somewhat like this. Okay, so let me say that it's a derivative. Its derivative that is the slope will be equals to m2. Okay, that is dy by dx for this function. Now remember, you are interested in calculating this angle, isn't it? Angle between the two curves. So basically finding angle between the tangents at the point of intersection and finding the angle between the curves both means the same. And you know from class 11 you have learnt one formula for calculating angle of intersection of two lines, and that is given by tan theta equals to modulus of m1 minus m2 divided by 1 plus m1 m2. So this is the formula that you have learned from class 11 in order to find the angle of intersection between two curves, two lines. Okay, and this is the formula that I'm going to use this time also. Okay, but this time in order to find m1 and m2, that is the slope, we will find out the derivatives of the two given curves. Okay, so if this is clear to you, let's see the first question for the day. So the first question for the day, so let me take question number 1 for you, 23(1). So we'll find the angle of intersection between the two curves. Okay, so number 1, the given curves are, okay, so we have xy equals to 6, all this is number 1, and the other one is x square y is equals to 12. Okay, so as you know, see these are the two curves. So for both the curves I need to find derivatives, isn't it? So from here, okay, so first and foremost, let's find out what is the point of intersection, So for finding point of intersection, what am I going to do is I'll take y equals to 6 by x. Okay, so substituting, you know that at the point of intersection, let's say this one, the value of xy is this value for this point of intersection is valid for this curve and this curve as well, both the curves. So that's why from here what I'm going to do is I'll find out the value of y, and that value of y I'm going to put in equation 2, because the value of x and y at the point of intersection is valid for both the equations. So that's why the y equals to 6 by x will be valid for this also, second equation also. Okay, so substituting y equals to 6 by x in 2. So let's see what do we get. Okay, so we get so x square into y. Y is 6 by x is equal to, so you have 12. Okay, so x and x gets cancelled. So from here, keep x out here and bring this 6 to the denominator. You get 2. Okay, so therefore your value for y will be 6 by x, which is 2. That is 3. That means what is the point of intersection out here? X is turning out to be 2 and y is 3, isn't it? So that's why therefore the point of intersection is 2, 3. That means we need to find the slope of the tangent at this point. Okay, because you have to draw a tangent at the point of intersection, isn't it? So we will find out slope for both the curves, slope of tangents for both the curves 1 and 2. Okay, so differentiating 1. Okay, so differentiating 1, what you get is, it is x into y. It's in the form of u into v. So differentiate x and keep y as it is. So it becomes y into derivative of x is 1 plus keep x as it is, and the derivative of y is going to be dy by dx is equal to, so you have 6 out here, so the derivative of 6 is 0. So from here your dy by dx turns out to be how much? So you bring this out here, so you get minus y by x, and you have to find dy by dx at the specified point, and the specified point out here is 2, 3. Okay, so your slope is going to be x is 2, y is 3, so it's gonna be 3 by 2. Okay, so therefore slope of the first curve, so slope of the tangent of the first curve. Okay, so let me call this as m1. So m1 is how much? Minus 3 by 2. So the slope of the, remember, slope of the tangent to the curve 1 at 2, 3 turns out to be minus 3 by 2. Okay, now similarly, I don't have space here, but still I'll try to do this. So differentiating 2. Okay, so what we will get? Let's see. So derivative of x squared is 2x and keep y as it is, plus derivative of y is dy by dx, keep x squared as it is. So you get x squared dy by dx is equal to 0. Okay, so from here, what is the value of dy by dx? Let's see. So dy by dx turns out to be, first take this minus 2xy out here. Okay, 2xy comes out here and becomes minus 2xy. This x squared comes to the denominator, so you get minus 2y by x. Okay, but you need to find dy by dx at the specified point 2, 3. So this turns out to be minus, so y is 3, remember, so 2 into 3 by x is 2, so it turns out to be minus 2. Okay, so therefore you can call the slope of the tangent of the second curve to be m2. So m2 turns out to be minus 2 out here. Okay, so I don't have space here. You may pause the video and note down till here. Now all of you know that we calculate the angle of intersection. Okay, so now we know that we calculate angle of intersection using the formula tan theta equals to modulus of m1 minus m2 divided by 1 plus m1 m2. So this is the formula, isn't it? So let's find out then. So let's simplify this. So this is modulus of m1 is minus 3 by 2. It is minus 3 by 2 minus m2 is minus 2 divided by 1 plus m1 m2. m1 is minus 3 by 2, m2 is minus 2. Let's simplify this. So this and this gets cancelled. Okay, so when you simplify this, this becomes minus into minus is plus. So 2 minus 3 by 2 divided by this is minus into minus is plus. So 1 plus 3 into 1 is 3. Okay, so this is going to be, so 2 2s are 4, 4 minus 3 is 1. So this is, in the numerator we have 1 by 2, in the denominator we have 4. Okay, so when you simplify this, you get 1 by 8. Okay, so therefore you get tan theta equals to 1 by 8, isn't it? So therefore your theta turns out to be, bring this tan over there, so you get tan inverse 1 by 3. Okay, so this is the angle of intersection. So that is the angle of intersection between this curve, curve 1 and curve 2 turns out to be tan inverse 1 by 3. So if you want to use the calculator and find out what is the angle, you can do that also. Okay, otherwise you can leave your answer to be this much. All right, so you may pause the video and note down your solution. Now let's look at this particular problem. So earlier, see, I have done only one problem. 2 problems you can try by yourself. It's same. Okay. Now number 24. The second question for the day says, prove that the curves this one and this one intersect at right angles at this particular point. That is, the angle of intersection between these two curves is 90 degrees. That's what we need to find. Okay. The given curves are, let me note down, the given curves are, okay, so one is y equals to x square minus 3x plus 1, and okay, so let me call this to be equation number 1, and another one is x into y plus 3 is equals to 4, and call this to be equation number 2. Okay, now do we need to find point of intersection? No, because the point at which we need to find the angle is given. So this is 2 minus 1. So no need to solve these two like earlier problem. So we can directly start differentiating. Okay, so differentiating 1 will give you dy by dx is equals to 2x minus 3. Okay, and from here, if you want to find dy by dx at the specified point, that is 2 comma minus 1, so it becomes 2 into, in place of x we have 2, so this turns out to be exactly 1. Okay, now similarly we will differentiate 2. So when you differentiate x, it becomes 1, and you have to keep y plus 3 as it is, plus now keep x as it is and differentiate this part. So you get dy by dx plus 0. Okay, so dy by dx plus 0 is just dy by dx is equal to 0. So from here your dy by dx is first bring this out here, so you get y plus 3 divided by x. Okay, but you need to find dy by dx at the specified point. Okay, and the specified point is 2 comma minus 1. So minus y is minus 1 plus 3 divided by x is 2. So this is how much? Minus 1, because this is 2 and 2 gets cancelled, so you have minus 1 out here, right? So therefore the angle of intersection, that is tan theta, will be equals to, all of you notice. Okay, so you can call this as you can call this as m1, and you can call this to be m2. Okay, so this is m1 minus m2 by 1 plus m1 m2. Let's put the values. Okay, so from here you get m1 is 1 minus m2. m2 is minus 1. Okay, so 1 plus m1 is 1 and m2 is minus 1. Okay, right. So this is numerator is 1 plus 1 by, this is denominator is 1 minus 0, which is undefined, isn't it? But all of you know that the value of tan theta becomes undefined only if the value of angle is how much? 90 degree. Okay, So therefore what we see here is, from here we see that theta is equals to nothing but 90 degree. Okay, so therefore the curves 1 and 2, okay, the curves 1 and 2 intersect at right angles at the point 2 comma minus 1. I hope this is clear to you. You may pause the video and note down your solution. Right, so let's see this one. So question says find the condition that the curves this one and this one intersect orthogonally. Orthogonally means perpendicularly. Right, so let's see how to do this. Same, it's also similar. So the given curves are, so it is 2x equals to y square, call this as 1, and the other curve is 2xy is equals to k, call this to be equation number 2. Okay, now do we have any this thing given to us, point of intersection given to us? No, right? So we want to find what is that point. So here what am I going to do is, from here you can find what is x. So x is given to be from here y square by 2. So therefore equation 2 becomes, okay, so when you put x equals to y square by 2 in equation 2, you get 2 into x. X is y square by 2 into, you have y is equals to k. So 2 gets cancelled. So from here you get y cube is equals to k, and from here y turns out to be k to the power 1 by 3. Okay, so from so therefore let's not write from. So therefore x equals to, now all of you know it is y square by 2, isn't it? But y is, okay, so let me write 1 by 2 first. So into y square, but in place of y we have k to the power 1 by 3. So how much is this? This is 1 by 2 k to the power 2 by 3. Okay, so this is the value of x. So therefore point of intersection is how much? One is k, right? X is k and y is x is how much? X is this much. I'm sorry, x is 1 by 2 k to the power 2 by 3 comma y is k to the power 1 by 3. So this is the point of intersection. Now question has said that they have to intersect orthogonally. So given is theta equals to 90 degree. Orthogonal means perpendicular. So therefore you must have tan theta equals to tan 90 degree, right? Which is how much? Which is obviously 1 by 0. Undefined, no, 1 by 0. Or you can write this as sine 0 or sine 90 degree. Just wait a minute. So you can write this as sine 90 degree by cos 90 degree. That also can be done. Okay, so what we can do here is tan theta. All of you know it is m1 minus m2 by 1 plus m1 m2. Yeah, by the way, I have not found what is m1 and m2, isn't it? So we have to find that also. So let me erase this for now. This is not required. Okay, so let's differentiate one. Okay, so differentiating 1 we get, okay, so you get with respect to x, remember, so this is 2 into 1 is equals to, so derivative of y square becomes 2y dy by dx. So 2 gets cancelled. So from here you get dy by dx equals to 1 by y. Okay, so at the specified point, so dy by dx at the specified point, so specified point is 1 by 2 k to the power 2 by 3 comma k to the power 1 by 3 is equals to 1 by y. Y is k to the power 1 by 3. Okay, so you can write this as k to the just wait a minute. So you can write this as m1. So m1 is how much? K to the power minus 1 by 3, isn't it? So this is your m1. Please remember this. So I don't have space here. You may pause the video and note down till here. Now let's differentiate this 2, equation 2. So differentiating 2, so you get, right, so here you have x into y form. So you have 2 into, okay, so derivative of x is 1. So you have keep x as it is and find the derivative of y. So you get dy by dx is equal to, you have k is 0. So bring this 2 out here. So from here you get y plus x dy by dx is equals to 0. From here dy by dx turns out to be minus y by x. But at the point, specified point, your dy by dx, that is at the specified point, half k to the power 2 by 3 comma k to the power 1 by 3, it turns out to be minus y is k to the power 1 by 3. Okay, x is 1 by 2 k to the power 2 by 3. Okay, so this becomes, so let me call this to be now m2. So m2 is equals to how much? It is minus, okay, so this half becomes 2, this 2 goes up, so it becomes k to the power 1 by 3 minus 2 by 3. So this is how much? This is exactly minus 2 k to the power minus 1 by 3. So I got my m2 also. Okay, now let's see the next part. See, this is my m1. I got m1 also. Okay, so I got m1 to be this much and I got m2 also at the same time. Okay, now we know that theta is how much? The angle of intersection between the curves is given to be 90 degree, isn't it? So what we can do here is simple. So it is given that tan theta is equals to tan 90 degree. Okay, so formula for tan theta is modulus m1 minus m2 by 1 plus m1 m2. Okay, and this is nothing but sine 90 degree by cos 90 degree, which is 1 by 0. Now do the cross multiplication. Okay, kindly do the cross multiplication. Or why to do all these things? No, let's not do this. So we know that tan theta is 90 degree. That means the angle of intersection between the two tangents is 90 degree. So it means that the tangents are perpendicular to each other, isn't it? So if they are perpendicular to each other, it means that the product of their slopes must be minus 1, isn't it? So if the product of their slopes is minus 1, so let's see how much do we get. So m1 is k to the power minus 1 by 3 into m2. m2 is given to be minus 2 k to the power minus 1 by 3 is equals to minus 1. So let's simplify this. So after simplifying this, we get our answer. Okay, so we have minus 2 k to the power minus 1 by 3 into k to the power minus 1 by 3 is k to the power minus 1 by 3 whole square is equals to minus 1. This and this gets cancelled, isn't it? So we have k to the power minus 2 by 3 is equals to 1, isn't it? So from here you get, see, you get we can say 1 by k to the power 2 by 3 is equals to how much? It is 1, yes or no? Okay, so then what do we get here is, we get k to the power 2 by 3 is equals to 1, and 1 can also be written as 1 by 2 to the power 3. So from here what do we get? We get the value of k to be 1. So that means whenever k is equals to 1, then we say that these two curves intersect orthogonally. Okay, so therefore the required condition is k equals to 1. So whenever the value of k is 1, then these two curves intersect orthogonally with each other. Okay, so pause the video and note down your solution. So let me show you the last problem. Prove that the curves xy equals to 4 and x square plus y square equals to 8 touch each other. In fact, you can do the sum by yourself. I'll just tell you, I'll just give you the hint. So this is one curve and this is another curve. So in order to show that these two curves just touch each other, just touch each other, so this is your point of intersection. Okay, so find the point of intersection and find the slope of the tangent. So if the slope of the tangent comes out to be equal, suppose let's say this is the tangent, let's say, okay, so let me draw a proper diagram. So let's say this is the tangent. Okay, so let's say this is the tangent. So this is the tangent for both the curves, isn't it? So if these two curves touch each other, then there's only one tangent which is common to both the curves, isn't it? And since it is one tangent, then the slope of the tangent for both the curves at the point of intersection will be same, isn't it? Slope of the tangent will turn out to be same. So what you do is solve this, call this as equation 1, call this as 1 and call this as 2. Find point of intersection. Okay, find point of intersection. Find point of intersection. Okay, next is differentiate 1 to get m1 at the point of intersection. Next you get differentiate 2 to get m2. Okay, so finding m1 and m2, if you get m1 equals to m2, if you get m1 and m2 to be equal, then it means that 1 and 2 just touch each other, they do not get intersected. That's the meaning of this, right? So you may pause the video and note down your solution. Okay, and with this we close our exercise on tangents and normal. Thank you very much.